Hello everyone, welcome to my channel Hypermesh Basic to Advanced. So to have a bit of a background about my channel, so in this channel I make videos related to FE and Hypermesh. So if you are new to this channel and interested in these topics, you can consider subscribing to this channel to get regular updates. And if you are already a viewer but not yet subscribed, kindly consider subscribing as it motivates me to make more videos. Correct? Okay. So moving on to today's topic. So in today's video, we are going to discuss random vibration analysis. Okay. So first of all, what is random vibration analysis? So if you all had seen one of my previous videos on frequency response analysis. So in frequency response analysis, what we did was we analyzed the structure or the object under the influence of an external frequency, correct? And we observed its behavior and response under that frequency load, correct? So random vibration analysis is going to be something similar, but the only difference which will come here is in this we will have multiple frequencies which will be coupled and it will be applied to this structure, correct? So we are going to observe the behavior of the structure under the coupled load, correct? Okay. So as I told, this will be similar to frequency response analysis. Okay, so the steps here will also be very similar. So I'm not going to detail all the steps. Okay, if you want to know the steps in details which were in the frequency response analysis, you can just refer to my previous video on frequency response analysis. Otherwise, this video will get a bit longer. Okay. Okay, so if you had seen my frequency response analysis video, I'd use the same model, correct? And that I had constrained all the 4 holes for the 6 degrees of freedom, if you can see here on my screen, correct? Then I had made a D area load collector, which I had used on the center node for the center hole, correct? Then I had created the R load collector, correct? So the difference between frequency and vibration response analysis, as I told, here we will have multiple frequency inputs, correct? So what we will do is instead of only one R load collector, we are going to use two R load collectors. Okay. Same thing will be for the table D1 load collector. If you see, instead of only one table D1 load collector, we will be using two table D1 load collectors. Correct? So R load and table D1, there will be two load collectors. Correct? Then frequency response load collector, it will be same. Correct? And then we have the table R&D one load collector. So what is this load collector basically is? I can show you just here. So basically this load collector is used to define the random frequencies, correct? Okay. So after that, we will define the rand PS load collector. Okay. And by the way, this table R&D one load collector, you can just go to the card image and select table R&D one, and you can give the number of what you call data points here. I've used 4 data points. You can use as much as you want according to your need, correct? Okay, so the RAND DPS. So the RAND DPS one, the card image will be RAND DPS. Okay, so this load collector is basically used to couple the what you call the load steps, the frequencies, correct? The frequency loads. So if you can see on my screen here, I have this J, K, X, Y, and TID column, correct? So what I have done is I have selected the first load collector here and the second load collector here. Then I have given X and Y and the table ID table random one, correct? So second row I have for J and K both I have selected the second load step, correct? And I have used the X value, Y value and table random one, correct? And in the third row I have coupled the frequency load step 1 and the frequency load step 2. I have used the X value and Y value and I have used this random table, correct? So if you want to see these values in details, you can just visit my website, the blog post. In that you will have all the values given in detail. I'll pin the link of my website in the description. You can just go to that and just check out the blog post there. Correct? Okay. So, okay, as I said, these two load steps which we will refer in the uh, RAND PS load collector. So where are those load steps? So if you go here in load steps, I have defined two load steps here. You can see. So one is frequency response here. This is for the first frequency load, R load, correct? And the frequency response 2, it is for the other R load, correct? Okay, so these two frequency load steps we have referenced in the this RAND PS load collector, correct? Okay, so what is next? So as in the previous frequency load collector, I have defined the material as steel. I have used the same values, correct? If you can see here, and the property I have used the shell property with a thickness of 2. If you can see, correct? Okay. So basically, we have the model. We have defined the material and the properties. We have defined the load step, correct? Two load steps for each of the frequencies, and we have defined the load collectors for the random vibration, correct? So what is next? So next we need to define the output cards. Okay, if you can see here, there is cards here. If I just expand this, you can see there's a global output request card. So in this global output request card, I have selected stress. You can select displacement also if you want, correct? And whatever strain also if you want, you can select to output the results, correct? But for now, I have only used stress. Okay, so if you can see stress, I have checked here. And the output format here, which we will be using for random vibration, it will be output 2, correct? After this, under the random field, okay, if you can see here, I have selected it as PSDF, correct? Okay, and this is all in the output request card, correct? If you want displacement, you can just check it, select the same output format, and it will be there, correct? Okay, next we have global case control. So what is the use of global case control here? Here we have to select the random card. Okay, and here we have to reference the RAND PS load collector. If you remember what we have created in this load collector RAND PS, correct? So here we'll reference the RAND PS load collector. So this under the global case control card. Okay. So next, what is there? Next card is case unsupported cards. So in this, what we are basically doing is we are basically plotting the displacement of this node. The node used here is 19, correct? So this is along the z direction. T3 means z, translation 3, correct? You can use T1, T2, T3, whatever you want. For this video purpose, I have selected T3. This is 19. You can use any other node number of your choice which you want to visualize, correct? XY plot we are creating for the displacement PSDA node 19 translation 3, correct? So this is all the setup for this random vibration analysis. So after this, we'll just go to Optistruct in analysis. If you can see analysis, Optistruct, and we'll just select the export options to all, run options to analysis, and then we can click on Optistruct. That will just run the solver, correct? So I've already run the solver, so I'm not going to run it again. I'll just go and display the results. Okay. Okay. So now we are in Hyperview. So this is somewhat what the results will look like, correct? You can see my screen here. I'll just expand this. Okay, this is how the results will look like. You can see my screen here, correct? So this will happen after you click on Optistruct and run the solver. Once it will be completed, you can click on the results and Hyperview window like this will open. Okay, and then you have to go to the contour tab and click on apply. This will come. Okay. Okay. So if you can see here, we are in the first load step, the first subcase frequency response. There are three: frequency response 2, for the other wave, and for the random vibration case, there's a load step automatically created. Okay. Okay. So if you can see the pattern here, you can just see it. Okay. So if I, and this is the what do you call, the graph for the node 19, correct, which we plotted. Okay. So if I can just play it here, this play button, you can see how this pattern is changing, how the power spectral density is reducing and then it's increasing again, and you can see the stress values again increasing. Okay. Okay. So if you can see it again, it's reducing as it goes down, then starts increasing again. Okay. Fine. So this is for the first case. For the second case, the pattern will be something like this. Okay, and we'll click on play. Okay, so for this, as the PSD is decreasing, it's increasing. You can see it here, correct? Okay, so, and these are the, what do you call, stress values, correct? Then we'll go to the third case, which is a random case, correct? We'll just click on apply and you can see the pattern here. Then we'll click on play and you can see it goes on decreasing. Okay, and then it's increasing. You can see here, correct? Okay, so apart from this PSD stress result type, we have one more stress called RMS stress, correct? Root mean square, if you know. So we'll just click on apply, and but you will see that there will be no results here. For this, we have to change this frequency from here to simulation 1. Okay, and then you can see the pattern will appear here, correct? Okay, yeah. Okay, so it got changed here. Okay, so you can see the pattern will appear here, correct? So this is for the root mean square stress, correct? RMS stress. Okay, so basically this is how you will do a random vibration. So in this I have used only two frequency. You can use multiple, maybe 5, 6, 10, what you wish. In real world scenarios, it's more than that. It's a combination of multiple waves. So it depends on your use case. So you can use as many numbers as you want. Okay. So basically this is how you do a random vibration analysis. Okay. So this is all for this video. Hope you got to learn something new. Okay. And don't forget to subscribe my YouTube channel and follow my Facebook and Instagram page for regular updates. And you can also check out my blog posts. I just post these tutorials on my blog page also. Okay. And one more thing, if any one of you have seen my previous videos, I had mentioned I have a finance blog too. So I'll just pin the link for that in the description and the comments also. So if anybody is interested in finance, you can check it out there also. So a recent development in my finance blog, I have just made some calculators like some home loan, car loan EMI, and if you, any of you guys are interested in that, you can just go out there and check it, and it will be good if you can give me some feedback on that. Okay, so thank you for watching my video. Keep learning. See you all in the next video. Bye.